Good morning, dear students. Good morning, everyone. Welcome back to another session of Physics Live classes. Now, as we are closing in, now, as you know, you have exams coming on day after tomorrow. Hope you are in the final stages. And today, we thought of taking a couple of chapters together, dual nature of matter and radiations, atoms and nuclei. Can you all hear me? Can I have a response, please? All of you, good morning. Welcome back, everyone. Am I audible? Am I audible? Please respond in the comment box, everyone. Right. Okay, so today's session is going to be really important because we will be discussing all the important questions from these three chapters, and if you sit through the sessions, you are going to get the questions for sure. I promise. Because the questions are, again, as I told you in the last session, the questions are carefully selected, and these are all from the previous papers, and these are done in such a way that the whole chapter is covered. Once the session is done, you know, we will have gone through all topics. We'll have gone to every nook and corner of the chapter. We'll have done all types of questions, all concepts, and you know, I'll be telling you the most important areas to focus while doing the descriptive part as well. Okay, right. Can I have a response, please, everyone? Just give me a second. Okay, shall we start now? Yes, Sean. Sanush, shall we start now, everyone? Okay, right, I'll start off with dual nature of matter and radiation. Then I'll move to atoms and finally end with nucleus. All right. So, let us start. Let us go to the first question. What will be the ratio of de Broglie wavelengths of proton and alpha particle of same energy? Proton and alpha particle of same energy. First of all, what is de Broglie wavelength? Every moving particle has a wave associated with it. Every moving particle, be it you or me, or even an electron or the spin, you know, if it is moving, it has a wave associated with it. And that wave is called de Broglie wave or matter wave. De Broglie wave or matter wave. And de Broglie wavelength is given by lambda is equal to h divided by mv. H is Planck's constant, m is mass of the particle, v is velocity of the particle. There is a condition for this. What is the condition? What if the particle is at rest? If the particle is at rest, that implies velocity is equal to 0. If velocity is equal to 0, tell me what's going to happen. Velocity 0 means denominator becomes 0. And any number by 0 is infinity. Wavelength is infinity. So if the particle is at rest, wavelength is infinity, which means wave does not exist. Okay, so the condition is clear. If the wave is to exist, the particle should be moving. The particle should be moving, right? The particle should be moving. Okay, so that is the first point. Lambda, every moving particle will have a wave associated with it. Okay, an electron has a wave, you have a wave, I have a wave, even the spin has a wave. It doesn't matter whether it is a living organism or not. All right. Anyway, the wave is called de Broglie wave. De Broglie wave or matter wave. De Broglie wave or matter wave. And the de Broglie wavelength is given by lambda is equal to h upon mv. H is Planck's constant, m is the mass of the particle, v is the velocity of the particle. Okay, right. So velocity 0 means particle is at rest. Infinity, no wave at all. So I'm going to write few equations now. Look at this second equation. In terms of energy, you can write the same equation as 2me. Lambda is equal to h upon root of 2me. The proof of which is not required now. Okay, lambda is equal to h by mv. This is in terms of momentum. This is called momentum. Mass into velocity is called momentum. And if you're talking in terms of kinetic energy, this is the equation. Lambda is equal to h divided by root of 2me. Kinetic energy is E. Now the third one is, if a particle, charged particle enters a potential. Charged particle enters a potential. This is called a potential. Alright, potential difference. And if a particle enters this, tell me, a positive particle enters this. Positive particle enters this. What will happen? Plus will repel plus, minus will attract plus. Plus will repel plus, minus will attract plus. Anyway, it is moving towards this plate. So it will have a kinetic energy, right? What is its de Broglie wavelength? Its de Broglie wavelength is given by h by root of 2mqv. 2mqv. Okay, h by root of 2mqv, where q is the charge of the particle, v is the potential. V is the potential. And next point, I'll write it. You know, this is de Broglie wavelength I'm talking about. All right. Next point is, you know, if it is an electron, if it is an electron, we can substitute every single value. You can substitute every single value. H value, mass of electron, 9.1 into 10 to the power minus 31. Then charge of electron, 1.6 into 10 to the power minus 19. If you substitute all those values, you will get 1.227 by root V nanometer. What is root V? V is the potential from which the particle is coming. Right. Okay, so that is only for electron. It was asked in a foreign paper once. You know what is the de Broglie wavelength of? An electron coming out of 100 volt potential. So you put that 100 here. Root 100 will be 10. Solve it. You will get the answer. Okay. Now another one for a gas molecule. Gas molecule, this is the equation, lambda 1 by lambda 2. Because if you take a gas, inside the gas molecules are in random thermal motion. They are moving continuously here and there, right? So if they are moving, they have de Broglie wavelength. What about gas molecules de Broglie wavelength? It is given by lambda 1 by lambda 2 is equal to root of T2 by T1. Lambda 1 is wavelength at temperature T1. Lambda 2 is wavelength at temperature T2. And there is another important question here which has come many times over the years. What is the proportionality of lambda with potential difference? Lambda again is potential differences. Lambda is inversely proportional to root V. So you can draw the graph. Lambda here, root V here. The graph will be rectangular hyperbola. The graph will be a decaying graph like this. Okay, lambda is inversely proportional to root V. And what if lambda is taken here and 1 by root V is taken here? 1 by root V. Lambda and 1 by root V. Look at this. 1 by root V is a single thing now. Single thing now. It is a single entity. Right. So this is like lambda proportional to direct proportionality, right? So graph will be a straight line. So this is the theory part. We will go to the question. I'll repeat one more time. What is de Broglie wavelength? For those who join late, I'm just repeating this one time. Look at this. You know, lambda is given by what? Every moving particle has a wave associated with it. It is called de Broglie wave or matter wave. De Broglie wave or matter wave. What is de Broglie wavelength? It is given by h by mv. H is Planck's constant. M is mass of the particle. V is velocity of the particle. And I said in the beginning, if the particle is at rest, velocity will be 0. Any number by 0 is what? Infinity. So wavelength will be infinity. For which particle? Particle at rest. So if I stay at rest, I have no de Broglie wave. If the pen stays at rest, it has no de Broglie wave. Alright. So matter wave X is only for moving particles. Okay. So I can say lambda is equal to h by mv. This is in terms of momentum. Alright. Next, in terms of kinetic energy, lambda is h upon root of 2me. Alright. and this is kinetic energy, this is mass. Third one, in terms of potential. Imagine a particle is entering a potential, or an electric field. So it will have a kinetic energy, right? What is its de Broglie wavelength? It is given by h upon root of 2mqv. Q is what? Charge of the proton. V is what? Potential difference. Okay, so you can put the mass and charge. I'll tell you which all particles they would ask. Number one, they would ask 1h1. Next is 1h2. Third is 1h3. Fourth is 2he4. These are the particles commonly asked in examinations. What is 1h1? This is called proton. What is proton? Hydrogen atom's nucleus is called proton. Hydrogen atom's nucleus. Hydrogen atom has what? A proton at the center and an electron around it. Okay, if you remove the electron, you have only proton, right? So hydrogen atom's nucleus is called proton. Hydrogen atom's nucleus is called proton. A hydrogen atom minus electron is called a proton. Okay, so hydrogen atom's nucleus. Now this is what? This is called deuteron. What is deuteron? Hydrogen has an isotope called deuterium. Deuterium's nucleus is called deuteron. Then what? Hydrogen has another isotope called tritium. Tritium's nucleus is called triton. Last one is helium nucleus, which is otherwise called alpha particle. Over the years, the board has asked only questions on these particles. Okay, you know, if you take the charge, what is charge? Charge is also called atomic number. Charge number is also called atomic number. This is called atomic number. Oh, atomic number. This is called atomic number, right? Atomic number is charge number. So you must take charge number as 2. Here charge number is 1. Here charge number is 1. Here charge number is 1. So for this one charge will be 2e. For this one charge will be e. For this one charge will be e. And for the last one also charge will be e. What about the masses? Mass here is 4m. Mass here is 3m. That number has a name, nucleon number or mass number. Mass number or nucleon number. Okay, now this is 2m. This is 1m. And depending upon the question, you have to put the mass here. If it is proton, put m. Deuteron, 2m. Triton, 3m. Alpha particle, 4m. And what about charge? Proton, 1e. Oh no, look at this. Proton, 1e. Deuteron, 1e. Triton, 1e. Alpha particle, 2e. Right? So, look at that. You can substitute them and find out. Okay, let's come back to that. Anyway, for electron, I have particularly found this out. What is the value for electron? Lambda electron. It is important. Lambda electron is 1.227 upon root V nanometer. So you just have to put the voltage value there, potential value there. And lambda 1 by lambda 2, this is for what? Gas molecules. Gas molecules. You know what gas molecules are doing? Gas molecules are randomly moving everywhere. Right? So they have de Broglie wavelength, and the de Broglie wavelength is proportional to 1 by root temperature. 1 by root of temperature. So that is why I wrote this equation. Lambda 1 by lambda 2 is equal to root of T2 by T1. And last one, you know, here T1 and T2 should be in kelvins. Okay, right. So lambda and root V, what kind of proportionality? Lambda and root V, that is a repeated question in board examination. Lambda and root V, how are they related? Lambda is, look at this, lambda, look at this. Lambda is inversely proportional to root V. Now if I take lambda against root V, lambda on y-axis, root V on x-axis, inverse proportionality, the graph will be a decaying curve like this. That's a previous question. What about lambda against 1 by root V? Lambda against 1 by root V. See what I'm doing? Lambda against 1 by root V. In this case, see this. Lambda is on y-axis. 1 by root V on x-axis. So it looks like they are in direct proportionality. Direct proportionality means what? The graph is a straight line. Direct proportionality means the graph is a straight line. All of you understood here? Everyone, please. Say yes, please, everyone. So we can go to the question. Right. Tell me, please. Shall I wipe it? Yes. All right. Thanks, Kirtana. Right. Okay, I'm wiping it. These are the equations you would need for like couple of questions ahead. Okay, Sinush, Devika, thank you. Martin, everyone, right. So hope you have written this. All right. Okay, right. So this is our first case. I'm going to see this question. What will be the ratio of de Broglie wavelength of proton and alpha particle? Many times this has come in papers. Proton and alpha particle. So entering with same energy. So energy is mentioned. So how can you take energy equation? Lambda is equal to h by root of 2me. H by root of 2me. Now first I am taking proton. What is proton? Proton is 1h1. Second one is alpha particle. Alpha particle is what? Helium nucleus. Proton is 1h1. Alpha particle is helium nucleus. Right. So what about the masses? I am writing proton. Proton is what? H by root of 2 into. What is mass of proton? Mass of proton 1m. What is energy? Energy I can put it here. Energy E. Okay. Now what about lambda alpha? Lambda alpha is what? H is same for both. Root is same for both. 2. I don't touch 2 either. Then what? Mass. Look at the mass number here. The mass number is 4 times m. 4 times m into capital letter E. Why is E same for both? Given in the question that they have same energy. Now we can find the ratio. It's so simple. Lambda proton by lambda alpha. They are asking you to find the ratio. Tell me what you're going to get. H by root of 2me divided by h by root of 2 into 4m into E. Let us cut the common terms out. What do we get? H and H are gone, 2 and 2 are gone, M and M are gone, E gets gone. So what are you left with? Nothing on the numerator. Denominator 1 by root 4. Right. Take it over the numerator. That is root 4, which is equal to 2. 2 means the ratio is 2:1. Answer is option A. All of you got it? Yes, Russell, Gabby, all of you. Understood this, everyone? Understood this, all of you? Right. Shall we move to the next one now? Tell me when this is done. Okay, right. So moving to the next question now. Question number 2. The de Broglie wavelength of a particle accelerated with 150 volt potential is 10 to the power minus 10. So first potential is given 150 volts. And the wavelength is given 10 to the power minus 10 meters. If it is accelerated by 600 volt potential difference, find the de Broglie wavelength. Okay. So let us see that question one more time. See this, the de Broglie wavelength of a particle associated with 150 volt potential. So first case, potential is given 150, right? Potential is given in the first case 150 volts. Even first case wavelength is given, lambda 1 is 10 to the power minus 10 meters, right? 10 to the power minus 10. If it is accelerated by 600 volts PD, 600 volts, second potential they have given 600 volts, then wavelength will be, now that you've written all the data down, it's going to be very easy for you. Why? This is a relation connecting lambda and potential difference. Think about it. Lambda and potential difference. How do we write it? Lambda is given by h by root of 2mqv, if you remember. Right. So lambda 1 is equal to what? H by root of 2mq into V1. Right. Lambda 2 will be what? H by root of 2mq V2. Same particle, So same mass, same charge. Same mass, same charge. The only thing that changes is what? Potential difference. Potential difference. All right. So tell me, I'm going to find the ratio. When I find the ratio, okay, I'm going to get these numbers cut. H and HR cut, 2 cut, M cut, Q cut. What do we get now? Root of 1 by root V1 by 1 by root V2. 1 by root V1 by 1 by root V2. Take the reciprocal, V2 divided by V1. So I can just substitute now. It's finished. So easy, so easy. Lambda 1 is given 10 to the power minus 10. Lambda 2 I need to find out. Lambda 2 is equal to root of V2 by V1. V2 is 600. 600 divided by V1, 150. Cut these numbers. That is what? They are cut with 4. Root 4 is equal to 2. So I got 10 raised to minus 10 by lambda 2 is equal to 2. Let us cross multiply. What do we get? Lambda 2 is equal to 1 by 2 into 10 raised to minus 10 meters. What is it? 1 by 2 is called 0.5. So the answer is 0.5 angstrom. 0.5 angstrom. Understood this, all of you? Understood this? You're definitely going to get the question from this part. Trust me on this, 100% sure. Okay. Are you still scared even after yesterday's class? I had told you, right? Okay, give your best, give your best. Still have time. You just go through the sessions, you just sit through the sessions. These chapters will be over. Trust me, this is going to be a complete revision of the chapter as well. Okay. All right. Yes. Everyone, if you have any difficulty, please tell me. I can repeat or I can give more clarification on any concept you want. I still need many responses, many more responses. Tell me, please. The more you respond, the longer I'll do. I'll have like electronics also if possible. So electronic devices. Okay, right. So that we can finish the second term topics. All right. Now, this is what? It all depends on how you respond. Okay, because I need to keep my energy level high as well. All right. So see this, the de Broglie wavelength of a neutron is at 27 degrees Celsius is lambda. What will be the wavelength at 927 degrees Celsius? So de Broglie wavelength at 27 is given. At 927 you have to find out. It is temperature dependence, right? They have given you the temperatures. Look at that. Lambda 1. First lambda, they have given it as lambda. First wavelength, de Broglie wavelength, right? The de Broglie wavelength at a temperature is given. What is the temperature? Temperature 1 is 27 degrees Celsius. Why am I adding 273? I had told you beforehand, everything has to be kept in Kelvin. Degree Celsius can be converted to Kelvin by adding 273. So that makes it 273 plus 27, 300 Kelvin. 300 Kelvin. Okay, right. Now I got lambda 1. I got temperature 1. What will be the wavelength? So second wavelength is the question. Right. At 927. 927. So second temperature is 927 plus 273. That will give me what? 1200 Kelvin. This is not given in the reader as such. But then why should I do this? It has less chance of coming. But I thought of doing it. It is still related. Why? It is still related to the concept. And I didn't want to take chances. Okay. I wanted the discussion to be comprehensive. I wanted this to cover everything. So I had to include this question. Okay. I had to include this question here. For that, I had to cut one question out from nucleus. Because this might figure in the paper. Right. Okay. You might think like, it is irrelevant at this point of time because, this is not mentioned in the reader or anything. But still, it has a chance. We have to be on the safer side, right? Okay, that is why. Anyway, I can put this. Do you remember the temperature difference? Lambda 1 is equal to, or lambda 1 by lambda 2 is equal to root upon T2 by T1. T2 by T1. T2 by T1. So let us put the values. What are the values? Lambda 1 is lambda. I need to find out lambda 2 is equal to root of T2. What is T2? T2 is 1200 T1 is 300, 0, 0 cut, 0, 0 cut. Root 12 by 3 is root 4. Root 4 is 2. So cross multiply now. Lambda 2 goes here, lambda 2 comes here. So lambda 2 is equal to lambda by 2. Lambda 2 is equal to lambda by 2. All of you understood this? All of you understood this? Lambda 2 is equal to lambda by 2. Answer is option A. All of you got this? If you respond, I'll do a quick short series tomorrow morning. If everyone responds, okay, maybe like 1 hour, I'll cover all the important areas. Okay, it all depends on how you respond. Everyone. Right. Thank you, Devika, Sanush, Gabby, all of you. Right. Martin. Right. Kirtana. Right. So, moving to the next question. Hope you finished this. Hope you finished writing this. Okay. Right. So, moving to the next question. A proton and photon. A photon. Photon things are different. What is photon? Photon is simply light. Quantum of light. According to quantum theory, light travels as packets of energy. Light always folds as packets of energy. Each packet is called quantum. Quantum of light is photon. You just have to know one thing. Photon's energy is given by h nu, or it is hc by lambda. Energy of photon is hc by lambda. Okay. Now, a photon and an electron have equal energy E. A photon, see, many of these questions can come as numericals as well. Okay. All right. You know, difficult questions won't come as MCQs. MCQs will be fundamental ideas only. 100% sure. 100% sure. I'm not saying 99.99. 100% sure. Only easy and direct questions will come as MCQs. Maybe, very less chance they might put one difficult question. All right. Why? Otherwise, you might score 100. Understood? Board doesn't want you to score 100. Okay. So, they might cut 1 mark down because past 95, above 95, there will be scrutiny. So, they have to restrict the number of cent per cent. Understood? Cent per cent. So, anyway, a photon and an electron have equal energy. Okay, that is the keyword here. Equal energy. Who has equal energy? Photon and electron have equal energy. Then lambda photon to lambda electron. What is lambda photon? Lambda photon. I've got it over here. Get this to left side. Lambda photon is what? hc by energy. Lambda photon is equal to hc by energy. That is equation number 1. What about lambda electron? Lambda electron we learned already. H by root of 2me. That is equation number 2. Then you may ask why I put both is same. This is energy of photon. This is energy of electron. Won't they be different? No. Why? Question says so. Look at that. They have equal energy. Look at that. I repeat one more time. First of all, I am writing lambda for photon. Where does it come from? Energy of a photon is equal to h nu, where h is Planck's constant, nu is frequency. And I can also write it as hc by lambda. Lambda is the wavelength, c is the velocity of light. Okay, and I get lambda from here. Look at that. I get lambda from here. Energy is equal to hc by lambda. Lambda goes this way, E goes that way. So lambda is equal to hc by E. That is for photon, not proton, photon. Now lambda for electron is what? H divided by root of 2me. Why am I taking this equation? Because they have mentioned energy in the question. So I must incorporate energy in my equation. Right. So both the energies are same. They say they have equal energy. So photons energy is E, electrons energy is E. So you can find the ratio now. Lambda photon by lambda electron is, tell me, hc divided by E by h divided by root of 2me. H by root of 2me. So let us cut the common terms out. H and H are cut. So anyway, remove all the constants. I'm concerned about E only, right? All the constants can be removed, right? They are asking for proportionality, proportional to, right? So I can remove constant C, I can remove 2, I can remove E. So what can I say? Proportional to, this is going to numerator. It is reciprocal, right? 1 by root E becomes root E by, this is 1 by E. So that means what? Lambda photon by lambda electron is proportional to root E by E is, root E by E is what? Oh no, this is root E into root E. Root E into root E. One root E gets cut. Lambda photon by lambda electron is proportional to 1 by root E. Answer is option B. All of you got it? All of you got it? Tell me, everyone. Come on, yeah, what is this? Tell me, you are writing the exam day after tomorrow. Right? And here we are trying to help you. Now, this was done intentionally because, you know, as I told you, if you see all the question papers, I'm willing to send the slides to you as well, because if you see the questions, you will understand one thing. It is a cross section of the whole chapter. Okay, cross section of the whole chapter. So, you know, in the end, if you go through the paper, even though it is like 10 or 12 questions, it'll have covered almost all areas. Okay. So that's what I'm trying to give, as many associated questions as possible. When I discuss one point, I'll tell you the associated points as well. Okay, right. So that is why I said this is like a quick revision of the whole chapter as well. Okay, right. So look at this. The kinetic energy of electron and proton is 10 to the power minus 12 joules. Can you see the question in full? Or is it cut? Is it cut on top? Can you see the question in full? Oh, so what to do? Can you read the question? The kinetic energy of electron and proton. Can you read the question? Because can someone please comment? Yes. Okay, Ashwin. Thank you. All right, Martin. Right, Mohammed. Thank you. Right. Okay. Readable. Okay. The kinetic energy of electron and proton is 10 to the power minus 32 joules. Kinetic energy of electron and proton. Both are the same. There lies the keyword. Kinetic energy is same. For both. Then keep that in mind and come over here. Then the relation between their de Broglie wavelengths is. We are talking about what? Electron and proton. Tell me, what is the equation for kinetic energy? Kinetic energy is equal to h by root of 2me. Oh no, again, why am I going to this equation? Because they mention energy, kinetic energy. Energy is mentioned. Energy is same for both. Energy is same for both means what? Energy is same for both means energy is constant. So I must introduce energy into my equation, or rather I must choose the equation with energy in it. So what is the equation for lambda? H divided by root of 2me. So let us write for the particles. Electron and proton. Lambda electron. What is lambda electron? Tell me, lambda electron is H divided by root of 2m electron into E. Lambda proton is H by root of 2m proton into E. Okay. Now, what is the ratio? I am finding the ratio. H is the same for both. 2 is the same. Capital E is also same. Only thing that has changed is mass. So I can say lambda electron by lambda proton. What is it? What is it? When you take the ratio, what is it going to be? H and H cut, right? Oh, I'll do it. H by root of 2 MeE by H by root of 2 MPE. Okay, so cut this H and H, 2 and 2, E and E. Finally, you get lambda electron by lambda proton is equal to, take the reciprocal, 1 by root ME by 1 by root MP. 1 by root ME minus 1 by root MP. What is it? Take the reciprocal, root of MP divided by ME. Okay, so which mass is more? Proton's mass is more than that of electron. Proton is much heavier than electron. Proton's mass is very large in comparison with electron. So if numerator is large here, this numerator also should be large. Lambda electron should be greater than lambda proton. Lambda electron should be greater than lambda proton. Or you can directly write it. Lambda is inversely proportional to M here. Look at this red circle. What is the kind of proportionality you have? H is constant, 2 is constant, E is constant. What is the proportionality? Lambda is inversely proportional to M. Inversely proportional to M means lesser the mass, more the wavelength. Lesser the mass, more the wavelength. So lesser mass is for electron. Lesser mass is for electron. Wavelength is more for electron. Lesser the mass for electron, more is the wavelength for electron. So this is the answer. So in 1 second you can get the answer. You don't have to do all these steps. Okay, just look at this equation and then see the proportionality. Lambda is inversely proportional to mass. Inversely proportional to mass, or rather square root of mass. Hope you got it. All of you got it? Answer is option A. I'm moving to the next question now. All right, second part of this chapter. This is about dual nature. Photoelectric effect. Photoelectric effect. Okay. Shall we go to this part, this question? Everyone, please. Okay, right. So this is what? When the light source is kept 40 centimeters away from a photocell. Photocell is nothing but the original experimental setup you learn in Leonard and Hallwach's experiment. Do you remember the original photoelectric effect experiment? Look at this. You have a glass chamber. You have an evacuated glass chamber. This is an evacuated glass chamber with a glass window on it. And there are 2 electrodes. This is connected to negative. The other one is connected to positive. Negative electrode. This is positive electrode. What's happening now? Light is coming from this. Look at that. Light is coming from this. Light is coming from this and hitting the surface. Light is coming from the source. It is hitting the surface. What kind of a surface is this? This is a photosensitive surface. Photosensitive surface. Photosensitive means what? When light falls on it, electrons are emitted. When light falls on it, electrons are emitted. What happens now? Electrons are moving to the right. You know, most of them, not all of them, not all of them, most of them. Why most of them? Why most of them are moving to the right? Most of the electrons are moving to the right. Why? Why? Because that plate is positive. That is pulling the electrons. Why is it pulling the electrons? Because that is connected to positive terminal. Right. So that plate is maintained at a positive potential. So it can pull electrons towards it. It can pull electrons towards it. And this will set up a current in the circuit. And that current is called photocurrent. Photocurrent. Okay, photocurrent. Now they are saying about what? Light source is kept 20 centimeter away from a photocell. Look at this. This distance is given. I'll use another color here. You know, this is the photocell. Okay, maybe like it is kept at a distance of 20 centimeters. Okay. Now you are increasing the distance to 40 centimeters. 20 centimeters, 40 centimeters. Stopping potential will be. I need you to learn two things here from this chapter. First one is this. Intensity. When you think about intensity, what does it mean? Intensity, actually intensity of light. How can you increase the intensity of light? By moving the source towards the window. How can you reduce the intensity? By moving it away from the window. So just know that you can change the intensity by moving it away from or towards the window. All right. So anyway, intensity means what? Number of photons. Actually, it is number of photons per area per second. But I could say intensity is proportional to number of photons. The more is the intensity, the more is the number of photons. The more is the number of photons, the more is the number of electrons ejected. Why? Why? Tell me why. Tell me why in comment box. Tell me. Because if one photon gets one electron out, 100 photons would get 100 electrons out. Am I correct? One photon ejects one electron. See, basically this is photoelectric emission. One photon is coming in and it is getting one electron out. That's it. Got it? According to Einstein, this is one photon, one electron interaction. One photon comes in and gets one electron out. One photon comes in and gets one electron out. Okay. So maybe like 100 photons can eject 100 electrons. 1000 photons can eject 1000 electrons. 10,000 photons can eject 10,000 electrons. The more the number of photons, the more the number of electrons. And more electrons will constitute more photocurrent. More photocurrent. Okay. More photocurrent. Intensity more, number of photons more, number of electrons more, photocurrent more. Now second, frequency. How do you change frequency? I told you, you can change intensity by moving the source towards the window or away from the window. Away from the window. How do you change frequency? You can change the color of the window. Color of the window. You put a color filter on it, color paper. The filter paper and the color paper, no, transparent paper. If you put yellow paper, yellow photon will come in. If you replace that with blue paper, blue photon will come in. Right? So frequency can be changed. When frequency changes, energy of photon also changes. Why? Energy of photon is given by h nu. H nu. So frequency and energy are related, right? When energy of photon changes, energy of electron that it ejects. A more energetic photon can dig a more energetic electron out. Okay. If you are, just imagine like a man of like say 500 kilograms is lying on a bed. Can you lift him? No. But on the other hand, if a really strong guy comes in, he can easily pull him out, right? Right, yes. So the stronger the photon or the more energetic the photon, the more energetic the electron that comes out. So if electron is more energetic, more work will have to be done to stop it. So that is called stopping potential. Stopping potential will be more. You learned this in school classes, right? Imagine, say 10 people are running towards you. I am running towards you. Just imagine, forget about that. I am running towards you. You can obviously stop me because I'm a poor guy. I don't have too much of energy. But imagine Usain Bolt is coming at you, full charged, coming at you. Can you stop him? No. Or forget about that. A Ferrari car is coming at you. Can you stop it? No. Right. Because the more the energy, the more the stopping potential needed. Okay, if you learn these sequences, it's very, very, very easy now. I'll tell you one more time. This is called Lenard and Hallwach's experiment. Lenard and Hallwach's experiment. I'll tell you, photoelectric effect was observed by Hertz, Heinrich Hertz. Photoelectric effect was observed by Hertz and it was experimentally verified by Lenard and Hallwach's. Lenard and Hallwach's, and theoretically explained by Albert Einstein, for which he was awarded Nobel Prize in 1917. On the basis of what? Max Planck's quantum theory of radiations. Max Planck's quantum theory of radiation. So until that time, photoelectric effect was a tough nut to crack. Nobody could explain why it is happening. All right, many other phenomena were satisfactorily explained. Interference, diffraction, polarization, reflection, refraction, many scattering, many things could be explained using either ray concept or corpuscular theory or wave theory. And Einstein had to go back to this quantum theory by Max Planck. Max Planck actually did this for all radiations. Max Planck's quantum theory of radiations, again, Max Planck's quantum theory of radiations was applied by Albert Einstein to explain photoelectric effect. Okay, so too many people are involved. Do not have any confusions. Hertz observed this first. Leonard and Horvath did the experiment. Einstein gave a theoretical explanation. It was Albert Einstein who gave a theoretical explanation for photoelectric effect on the basis of Max Planck's quantum theory. Okay, anyway, this is what it is. Intensity more, number of photons more, number of photons more, number of electrons more, number of electrons more, photocurrent is more. So the more the intensity of light, the more photons will come out. The more the photons coming out, right? So the more the photons, the more will be the electrons ejected. The more is the electron, the more is the current flowing, right? Okay, so more current will flow, photocurrent. Now second sequence is frequency. Frequency, tell me, energy of photon, energy of electron, stopping potential. The more is the frequency, the more is the energy of photon. The more is the energy of photon, the more is the energy of electron. The more is the energy of electron, the more is the stopping potential. Okay, now let us come back to this question. You know, this is what they say, 20 centimeter is changed to 40 centimeters, right? Distance is changed, right? Distance is changed, right? So I can say, I'll wipe this. I'll have to make space here. So distance is changed. Distance is what? Distance is changed. Distance changed means what? Distance changed means intensity changes. Intensity changes. Frequency won't change. When distance is changed, intensity will change, frequency will never change. If intensity changes, only this sequence will be affected. Will stopping potential be affected? No. Stopping potential belongs to another sequence. If stopping potential is to be affected, frequency must change. So in this case, they are asking what will happen to stopping potential. That will remain the same. What was it? 0.6. So that will remain 0.6. Understood this? The question is very simple, but you have to know the concept. All of you, can I have a response, please? Everyone. Everyone. Should I repeat this? Should I repeat this? Okay. Okay, right. Thank you, Devika. Thank you, Sanush, Martin, Kirtana, all of you, right. Sneha, all of you, thank you, right. So you have to know the sequence. Here in this question, they say distance is increased. When distance is increased, what will change? Intensity will change. Say it again. Distance increases, intensity will change. Distance increases, intensity will change. Intensity will change, all these things will change. But nothing will change with respect to this sequence, right? If that is to change, frequency must change, right? Frequency changes when color of the window is changed, color of the window. You can cover it with different colors, I told you. So in this case, stopping potential remains unchanged. Okay, moving to the next question now. All right, moving to the next question now. Okay, so before that, I'll just draw the graphs as well. See this? You know, I have a graph. I told you this is the sequence. Intensity, number of photons, number of electrons, photocurrent. This is the sequence, right? Photocurrent. All right, I have a sequence. Now, how do you draw the graph? This is the first graph on the reader. Intensity against photocurrent. Tell me, can you predict the nature of the graph? Can someone predict the nature of the graph? You don't have to learn it by heart anymore. Come on, guys, tell me. Oh, I'll tell you. Anyway, this is intensity, number of photons, number of electrons, photocurrent. You know, you can say these guys are directly proportional. Directly proportional. Intensity more, number of photons more, number of photons more, number of electrons more, number of electrons more, photocurrent is more. So the graph will be what? The graph will be a straight line that's going up. It is what is this? Straight line that's going up. Direct proportionality. The graph is a straight line that's going up. That's going up. This is the nature of the graph. This is the nature of the graph. Right. Straight line that's going up. Okay. The graph is a straight line that's going up. Now, second graph is this. Second graph. I'm drawing the graph of frequency. Graph of stopping potential against photocurrent. You must have drawn this in school like this. Now this point is called a stopping potential, right? And that current is called saturation current. Hope you know the shape of this graph. Okay, I don't have time to explain why the graph looks like this. Okay, for the time being, since it is last time preparation, you just know the graph as such. All right. Now this is called saturation current and this is called stopping potential. Now I'm going to draw two cases. Intensity same. Intensity same. Frequency different. Intensity same, frequency different. Second case, intensity different, frequency same. Intensity same, frequency different. Intensity different, frequency same. Okay, I'm going to draw this graph. Can I have a response? Very few are responding. Look at this. Current is on y-axis and frequency, stopping potential is on x-axis. So I'm doing two cases. Intensity same, frequency different. So I'm drawing the graph. This is current here. This is stopping potential. Intensity same means what? Do you remember the sequence? Intensity same means number of photons same. Number of photons same means number of electrons same. Number of electrons same means photocurrent is same. So photocurrent must be same. Photocurrent must be same. So look at this. I'm drawing first graph, second graph, third graph. All of them have same photocurrent, right? Saturation current is same for all. But look at the stopping potentials. V01, V02, V03. They are different. Why are they different? Stopping potential is different. Why stopping potential is different? Energy of electron is different. Why is energy of electron different? Energy of photon is different. Why is energy of photon different? Frequency different. Why is frequency different? That is a condition I gave. Frequency different. Correct. So if frequency is different, this way you don't have to learn by heart. Frequency different means energy of photon is different. Energy of photon is different means energy of electron is different. Energy of electron is different means stopping potential is different. This is the greatest stopping potential. We take the magnitude only. Don't say that this is negative, this will be the smallest. No. We take the modulus only. We take the modulus only. So you can say V03 greater than, V02 greater than, V01. Or nu3 greater than, nu2 greater than, nu1. Frequency for third case is greater than, frequency for second case is greater than, frequency for first case. How do we draw it here? It's easy now. It's easy now. Easy. Right. Tell me how you're going to draw this. Here, intensity different. Intensity different. Intensity different means what? Number of photons different. Number of electrons different. Photocurrent is also different. Photocurrent is different. Tell me, photocurrent is different. How do we draw this? Photocurrent is different. So I'm drawing this way. I'm drawing this way, like this. Photocurrent is different. I1, I2, I3. I3 greater than, I2 greater than I1. But everyone has same stopping potential. Can you tell me why? Can you tell me why? Can someone tell me why? Stopping potential is same because energy of electron is same. Energy of electron is same because energy of photon is same. Energy of photon is same because frequency is same. How do we know? It is given in the question. Frequency is same. Correct? Understood this graph? Everyone understood this graph? These graphs are important, okay? 2 more questions to go. This topic is going to be over, okay? All of you understood this? Right, Sujay, thank you. Right, so moving to the next question. This one we did. Next question. Bohr function of a substance is 4 electron volt. The longest wavelength of light. The longest wavelength. Longest wavelength is called what? Threshold wavelength. What is the minimum frequency required for photoelectric emission? Minimum frequency required is called threshold frequency. The minimum frequency required for photoelectric emission is threshold frequency. For example, if this surface has a threshold frequency of 100 Hz, if 99 Hz frequency falls on it, P emission will not happen. Photoelectric emission does not happen. If P emission is to happen, minimum frequency needed is what? 100 Hz. That is the meaning of threshold frequency. So threshold frequency is what? Threshold frequency. This is called a threshold frequency. That is actually the shortest frequency. Threshold frequency. Okay. Then what is lambda 0? Lambda 0 is threshold wavelength. That is the maximum wavelength at which P emission would happen. So the condition is very simple. Photoelectric emission never happens below nu zero. Photoelectric emission never happens below nu zero or above lambda 0. Below nu zero or above lambda 0. If nu is less than nu zero, no P emission, photoelectric emission. If lambda is greater than lambda 0, no P emission. So maximum wavelength is lambda 0, that is called threshold wavelength. Minimum frequency is threshold frequency. Right, let's come over here, and then they have given you the work function. Work function is given by h nu 0. Work function is what? Minimum amount of energy required to take an electron out of a surface. Minimum amount of energy required to take an electron out of a surface. It is called work function of the material. Work function of the material. So phi is equal to h nu 0. That is phi is given 4 electron volt. Electron volt. How can you convert electron volt to joules? How can you convert electron volt to joules? You have to keep everything in SI. So SI system. 4 into 1.6 into 10 raised to minus 19 is equal to H value. Oh, I forgot, right? H nu 0 may be written as Hc by lambda 0. Why? Nu is equal to C by lambda. I repeat, phi, the threshold, work function, the minimum energy required. The minimum energy required for PE emission is phi. That is called work function. It is different for different materials. Okay, copper has a particular value of work function. Lithium has another value. Platinum has yet another value of work function. Got it? So each material has a unique value for work function. Okay, right. So phi is equal to h nu 0. That is Hc by lambda 0. Okay, I'll straight away get this. I'll get lambda 0 to the left. What I need is lambda 0. It is Hc by phi. So I'm putting the value of h. Planck's constant value, I hope you know, it is 6.6 into 10 to the power minus 34. Velocity of light is 3 into 10 raised to 8 divided by phi. Work function is given 4 electron volt. 4 into, I am multiplying with 1.6 into 10 raised to minus 19. Why did I do that? Converting electron volt to joules. That is how I convert electron volts to joules. Okay, now let us cut it out. Look at this. 1.6 into 4. 16 fours are 64. That gets cut with this. Roughly 1.6 into 4. 6.4. 6.4 gets cut with 6.6. So tell me what you're getting. 3 into 10 power minus 34, 10 power minus 8, 10 power minus 26. by 10 power minus 9. Oh, 19. So that is 3 into 10 power minus 16, 10 power minus 26 minus 19, 10 power minus 7. It is in nanometer. Nano means 2 more places I have to put. 300 into 10 raised to minus 9. 10 raised to minus 9 is called nano. 300 nanometers would be the answer. Closest to 1 is 310. Understood this, all of you? Everyone understood? Everyone say yes, please. All of you, all of you, all of you. Everyone. Come on, just be energetic. Be the fighter you are. Okay. Right. All right. So, look at this. I can see your face now. I can visualize your face now. Just stay pleasant. Just stay smart. Okay. Nothing is going to happen. Don't worry. Right. All right. All is going to be well. 100% sure. Now, the work function of metal is 1 electron volt. Work function of electron is 1 electron volt. Light to wavelength 3000 angstrom. Light to wavelength 3000 angstrom is incident on this metal surface. Velocity of emitted photoelectrons will be. Velocity of emitted photoelectrons. So you are given the work function. You are given the work function. You are given the incident light's wavelength. You are asked to find the velocity of emitted electrons. Right. So you have to trust Einstein on this. Tell me, according to Einstein, the incoming energy is used for two things. One, to get the electron out, h nu 0, that is also called work function. Second part will be given as kinetic energy to the electron. Kinetic energy to the electron. Imagine, say, you are getting 20,000 reals as your salary. Maybe like 7,000 would go to the expenditures. The rest is what? Rest is savings for you. Right? Same way, the incoming energy is spent for two things. One part to get the electron out. Second part to impart kinetic energy to the electrons. Okay, or forget about that. You just imagine you are taking food. Say 1000 joules of energy every day by food. By food. Okay, 1000 joules. And you are spending only 600. What will happen? Rest 400 will be stored as fat on your body. Then what? You will get bigger and bigger every day, right? Same way. This is what? One part is used for one thing. That is the incoming energy h nu is used for two things. One is h nu 0. This is to get the electron out. Okay. For example, if it is 100 joules, maybe like it will spend 20 joules in getting the electron out. The rest 80 is with the electron now. So I can call it half m v max square. We will take maximum kinetic energy. We will think about maximum fastest moving electron only. Automatically all other electrons will be taken care of. Okay. Imagine it this way. Imagine 100 people are running towards you. 100 people. Among them, Usain Bolt is also there. If you can stop Usain Bolt, it is implied that all others are stopped. Why? Usain Bolt is supposed to be the most energetic man in this world. Right. At least in terms of his kinetic energy, right? Okay, right. So same way, that is why I put V max square. I was trying to justify why I put V max there, V max. Okay, so get this left hand side, h nu minus h nu 0 is equal to half m V max square. This is called Einstein's photoelectric equation. Einstein's photoelectric equation. The very same equation for which he was awarded Nobel Prize. All right. And remember, if a numerical comes from this topic, I'm going to repeat this statement 3 times. If a numerical comes from this topic, if a numerical comes from this topic, if a numerical comes from this topic, it is 100% going to be based on this equation. Ask me why. Ask me why. Ask me why. Ask me why. Nobody is asking, so I'll tell you why. There is no other equation in this topic. Okay, there is only one equation. H nu minus H nu 0 is equal to half mv max square, which could also be written as H nu minus H nu 0 is equal to kinetic energy same as EV0. EV0 is work done to stop. Work done to stop. Work was learnt as QV. in potential. QV, same as EV0. So you have two equations here. Basically, you have two equations here, which you have to learn by heart. H nu minus H nu 0 is equal to half m V max square, and H nu minus H nu 0 is equal to EV0. EV0. All right. So I can put the values here. I've been given everything. So hope you have written this. Shall I wipe it and I calculate the values? Shall I calculate the values? Yes, yes, everyone. Sneha, Farhan, Sujay. Yes, Miva. Yeah, Johan. All of you, Farhan. Right, Martin, Russell, everyone. Shahini, Sanush, all of you. Thanks for responding. Okay. So I'm happy that you're all listening properly. Right. So look at this. This is my equation. H nu is what? H nu is equal to H nu minus H nu 0 is equal to half m V max square. All right. I'm going to put the values. Don't worry, if you are spending these 2 hours, it will be worth it. 100% sure that won't be a waste of time for you. You can trust me on this. You will get the questions for sure. Okay. So first I am putting the value. What is H? H is 6.6 into 10 raised to minus 34 into C. This nu is C by lambda, right? C is 3 into 10 to the power 8 by lambda is given 3000. 3000 into 10 to the power minus 10 is C minus. What is H nu 0? H nu 0 has a name. It is called work function. It is called work function. How much is work function? 1 electron volt. 1 into 1.6 into 10 raised to minus 19 is equal to half mv square. I repeat one more time. I'll tell you what exactly I have done. This is again one of the most repeated questions in this topic. H nu. What is H nu? Hc by lambda. H nu is Hc by lambda. H is 6.6 into 10 to the power minus 34. C is velocity of light. 3 into 10 raised to 8. By lambda is 3000 into 10 to the power minus 10. Okay. Hc by lambda. Hc by lambda. Now this is H nu 0 is called work function. H nu 0, it is given 1 electron volt. 1 electron volt is 1 into 1.6 into 10 to the power minus 19. Now why am I doing this? Electron volts to joule conversion. And half mv square on the right side. Tell me what? My throat is gone. Tell me what? 3 and 3 are cut. What am I getting now? 6.6 into. See the power of 10 carefully. 10 power minus 34, 10 power 8, 10 power minus 26 by 10 power minus 10, 10 power 3, 10 power minus 7, right, 7 minus, this is 1.6 into 10 raised to minus 19 is equal to half mv square. I'm done with it, finished. This is 10 raised to minus 26, 10 raised to minus 7. It is what? 6.6 into 10 raised to minus 26 and minus 7, minus 19. Minus 1.6 into 10 raised to minus 19 is equal to half mv square. Finished. Have you written until here? If you have written until here, I'll proceed with the steps. Now it's very easy. It's very easy. You can just substitute and find out. All of you got this until here? Can someone please tell me? Yes, Umaid. Yes, Umaid. Right. Can someone please tell me? Have you written until here? Or you got the idea until here? What about 1000? 1000. Where is this 1000? These 3 zeros are already taken with 10 raised to minus 10. That is how it is 10 raised to minus 7, Sujay. Okay. Alright, Devika. Thank you. Martin. Thank you. Sujay. Those 3 zeros are taken with 10 raised to minus 10, Sujay. Okay, fine. Right. So let us simplify this. 6.6 into 10 raised to minus 19 minus this. 6.6 minus 1.6. That is 5 into 10 raised to minus 19 is equal to half mv square. Half mv square. Half mv square. So I'll get this 2 to left hand side. 2 into 5. 10 into 10 raised to minus 19 by mass comes to denominator. Mass of electron is 9 into 10 raised to minus 31 is equal to v square. V square. Okay. 10 by 9. 10 and 9 are roughly cut. No problem. Look at the powers. They are so large, right? So large, right? 10 and 9 are cut. 10 power minus 19, 10 power minus 31. 10 power minus 31 goes to numerator. That will be 10 power plus 12 is equal to V square. So what will be V now? V is equal to square root of this. It is 10 power 6 meter per second. Understood this, all of you? 10 power 6 meter per second. Is that there? Yes, 1 into 10 raised to 6 meter per second. All of you understood this? Can I have a response, please? One more question or maybe two more questions. We'll take a break and go to atoms nuclei. All of you, you'll get the questions day after tomorrow. From this topic, you'll get the questions for tomorrow, day after tomorrow. Right. Okay, fine. So moving to the next question. Yeah, it's a graph question. You must have seen this in school. I'll do all types of questions here. Make it very quick. I'll make it very quick. Look at this. Okay, right. I have this graph. I have the graph of h nu. Look at this. I'm writing this equation. H nu minus h nu 0 is equal to half m v max square. That is also called maximum kinetic energy. Maximum kinetic energy. All right. H nu minus h nu 0 is equal to half m v max square. Now this looks like y is equal to mx. Y is equal to mx plus c. Y is equal to mx plus c is what? The equation for a straight line. Y is equal to mx plus c is the equation for a straight line. Look at this yellow circle. Look at this orange circle. Look at this orange circle. What is in place of y? In place of y, look at the orange circles. Y is half m v max square. That means on the y-axis, you are taking half m v max square. Look at that. I'm writing down Einstein's equation. Right below this, I'm writing the equation I know. I told you once, only straight lines equation needs to be learned. Okay, so y is equal to mx plus c. What is in place of y? Half m v max square. Y-axis has half m v max square, right? How about x-axis? Look at this. Look at this pink circle. Look at this pink circle. Look at this pink circle. In place of x, what do I have? What do I have? Nu. I'm certain about one thing now. The graph is a straight line. The graph is a straight line. Look at that. The graph is a straight line like this. If you extrapolate it, you know it'll touch here. If you produce it, it'll touch here. Now this length is called y-intercept. Y-intercept. It is given by c here. Y-intercept is c. Look at this green circle. Look at this green circle. This is the y-intercept. What is in place of y-intercept? It is h nu 0. And this is called x-intercept. This is called x-intercept. Okay, the point where the graph starts on x-axis. And that location is called threshold frequency. Threshold frequency. Okay, so look at this. It's very easy now. Just write down the equation. Never learn this by heart. It has come as a 2-mark question also. H nu minus h nu 0 is equal to half m v max square. Right below this, you write the equation for y is equal to mx plus c. Yeah, they can ask this in MCQ also. I'll show how the MCQ is asked. Okay, so tell me what? You know, yes, Rishabh, it can be asked. Okay, so this is called y-intercept. What is y-intercept? It is C. It is the point where the graph starts on y-axis. Y-intercept is the point where the graph starts on y-axis. X-intercept is the point where the graph starts on x-axis. Okay, right. Anyway, let us do this now. Can you tell me what y-intercept is? I'll tell you one by one. Y-intercept. What is y-intercept? Y-intercept. Can you tell me from the figure? It is C. C is equal to what? H nu 0. Do not worry about the minus sign because it is negative intercept. So just take the modulus. It is negative intercept. It is on negative y-axis. So do not worry much about that negative sign. So C is equal to H nu 0. This is called the work function, right? So how to find the work function? How to find the work function? Just take the y-intercept. Do this experiment. Plot it on a graph. Use a scale in your geometry box to find this distance. that will be the work function of the material. So if you want to find the work function, this is how you do it. You do the experiment, plot the graph, measure this distance, that distance is called y-intercept, and that is what the work function. Number 2, look at the slope. What is meant by slope? Look at this red line. Look at this red line. This red line. Slope is called m. Slope is called m. Slope is m. What is slope? M. M is equal to h. H is called what? Planck's constant. Planck's constant. So if you want to find Planck's constant, just find the slope of the graph. Just find the slope of the. So they have asked us in the past, suggest a method for finding Planck's constant from this graph. How do you do this? Do this experiment, plot the graph, find the slope. Slope means you can draw a tan triangle here, take tan theta. That will be the slope of the graph. Slope is tan theta. Slope is tan theta. You have learned this many times, right? Slope of the graph is tan theta. So if you find slope, what you found is? Slope is Planck's constant. Planck's constant. Third one, you know what is x-intercept from this? X-intercept. Can you tell me what x-intercept is? X-intercept is equal to, this is called x-intercept, and that location is called threshold frequency, the minimum frequency required. The minimum frequency required, okay, for photoelectric emission to happen. Now let us read the question. For photoelectric effect, the maximum kinetic energy EK, maximum kinetic energy EK is on y-axis, that is half mv max square, is plotted against frequency. Then slope of the curve, see the board, slope of the curve gives what? Planck's constant. In 1 second you have the answer, right? Slope of the curve gives Planck's constant. Understood this, all of you? Understood this, all of you? Everyone? Come on guys, tell me. Previous question, Rishabh, I'll just check. Previous question was what? Yeah, this will not come as MCQ, maybe. The previous question, that will come in a 2-mark question only. But I put it as an MCQ, so I just wanted to do that question, okay? Hope it's clear. Thank you, Devika. Right, the answer here is, if you want, you can write this down. I'll tell you a couple of more points here. This graph may be asked other ways also. In other ways also. Okay, right. So if you finish this, I'll draw 2 more graphs. Here I drew h nu minus h nu 0 is half mv max square, and I'll draw one more. H nu minus h nu 0 is equal to EV0. I can also draw the graph. H nu minus h nu 0 is equal to EV0. How do we draw this? Just like the old times. Y is equal to mx plus c. Y is equal to mx plus c. Now compare this. Tell me, what is in place of this orange circle? What is in place of this orange circle? EV0. What is in place of this green circle? What is in place of this green circle? It is frequency. So you can draw the graph now. Draw the graph now. This is the graph. Tell me, on y-axis, you must be taking EV0. On x-axis, you must be taking frequency. In this case, the graph was, again is what? What again is what? Kinetic energy against frequency. Kinetic energy against frequency. But this time it is EV0 against frequency. EV0 against frequency. Tell me what you are going to get. Number 1, graph will be obviously same shape. Okay, this location is called y-intercept. This location is called x-intercept, which is threshold frequency, right? So let us do one by one. First one. Tell me, what is x-intercept? This is called x-intercept. X-intercept from this graph is what? X-intercept. X-intercept is called threshold frequency. X-intercept is threshold frequency, the minimum frequency required for photoelectric emission to happen. The minimum frequency required for photoelectric emission to happen. Number 2, what about y-intercept? Can you tell me y-intercept? Y-intercept is C. What is in place of C? Can you see this orange circle? Can you see this orange circle? What is in place of orange circle? What is in place of orange circle? Y-intercept is C. Y-intercept is C. C is orange circle, which is h nu 0. H nu 0 is work function. So how to find the work function? Just find the y-intercept. Do the experiment, plot the graph. Do the experiment, plot the graph. Find the y-intercept. That is going to give you the what? The work function of the material. Now third point, tell me, again I can do one more thing, the slope of the graph. Look at this pink circle. Look at this pink circle, pink circle, pink circle. That is the slope of the graph, right? Slope of the graph. Slope of the graph is what? It is m. M is what? H. Directly that gives you what? Planck's constant. Planck's constant. All of you got it? All of you got it? Everyone, anybody needs it one more time? Otherwise, the next question is the last one in dual nature. I'll move to atoms and nuclei after maybe like 5 minutes break. Right? All of you got this? Come on guys, tell me please. Then I need you to draw one graph here. Look at this. You draw this graph also. Write the same equation. You draw it yourself and then tell me. You divide every single guy with E. Everyone with E. Everyone with E. And then draw the graph. This and this circuit. I'm dividing everyone with E. So it becomes H by E into nu minus H by E into nu 0. That is also previous question, V0. H by E into nu minus H by E into nu 0 is equal to V0. What does it look like? Y is equal to, what does it look like? Y is equal to mx plus c. Do it yourself and then see. What is on y-axis? What is on y-axis? Look at the orange circle. Look at the orange circle. On the y-axis, it is V0. On the x-axis, look at this green circle. Look at this green circle. On the x-axis, it is frequency. It is frequency. Now what? What is the shape of the graph? Shape of the graph is again a straight line. All the graphs are straight lines, right? All are straight lines. Right. And this is called x-intercept. That is, as always, threshold frequency. Y-intercept, this is called C. So let us write one by one. Number one, x-intercept. X-intercept is equal to what? Threshold frequency, right? X-intercept is threshold frequency. Am I correct? Then what? Then what? Then what? Then what? Then what? Tell me, what is y-intercept? Look at this pink circle. Look at this pink circle. Y-intercept. Y-intercept is what? Y-intercept. Number two, y-intercept. Y-intercept C is equal to, what is y-intercept C? H by E into nu 0, cross multiply. C into E is equal to H nu 0. So H nu 0 is what? H nu 0 is called work function. So this is how you find the work function. Suggest a method for finding work function using the graph. You have to do this, conduct this experiment, then plot this graph, then put the y-intercept, multiply that by charge of electron. Multiply that by charge of electron. What you are getting is the work function of the material. Third one, as always, is slope of the graph. Can you tell me what slope is? What slope is? Can you tell me what slope is? Look at this red circle. Look at this red circle. The slope is H by E. Look at the red circle. Look at the red circle. The slope is M is equal to H by E. So H is what? M into E. So that is how you find Planck's constant from this. How to find Planck's constant? Find the slope of the graph. Find the slope of the graph. Take tan theta, you will get slope of the graph. Find the slope of the graph, put it here, multiply by charge of electron. You will get Planck's constant. All of you got this? These three graphs are very important. Look at this. Graph number 1, this can come for 3 marks also. Graph number 2 and graph number 3. All are identical. All are identical. But the difference is what? First graph has half mv max square on y-axis. Second graph has EV0 on y-axis. Third graph has V0 on y-axis. That is only difference. All have frequency on x-axis. Frequency here, frequency here, frequency here. Okay, on x-axis frequency only, y-axis it keeps changing. First case half mv max square, second case EV0, third case V0. Alright, so here the answer is option C. Let us move to the last question on this slide. Okay, oh, that's done. That's all done. All of you got this? All of you got this? I'll just take a 3 minutes break. Then I'll come back with the rest of the questions, okay? Okay, everyone? Just 3 minutes. Okay, stay here, do not leave, stay here. Important questions are coming up. Atoms and nuclei. You will get the questions for sure. Atoms and nuclei. I'll cover all areas, important areas, okay? I'll cover all important areas from atoms and nuclei as well, okay? Just stay here, maybe I'll come back in 3 minutes, okay? See you guys, right. Hello dear friends, welcome back. Sorry for the extended break. Okay. Right, shall we continue? Shall we continue? Say yes please everyone. Can I have a yes from everyone? Yeah, after all it is like maybe like 45 minutes to 1 hour. That's it. I'll cover almost all important points from atoms and nuclei. Thanks Devika, thank you for this. Right, everyone, right Martin, right. Yeah, okay, fine, right. So let us start with this question. In the nth orbit, the energy of an electron is minus 13.6 n square electron volt for hydrogen atom. The energy required to take the electron from the first orbit to second orbit will be. So I'll tell you a few things about this. You know, what did we learn first? You know, we had Thomson's plum pudding model about the structure of atom, and that was discarded. Thomson's plum pudding model, according to which an atom is a positive sphere with electrons randomly embedded inside, like seeds in a watermelon, okay, or plums in pudding. Now that was called plum pudding model, right? But the problem was the model, according to the model, one second. Okay. Right, shall we continue? So the problem for the model is that according to plum pudding model, the atom is entirely occupied by matter. But you know, later on this was discarded after Rutherford's alpha particle scattering experiment, or that experiment is also called Geiger and Marsden experiment. Geiger and Marsden were research associates of Rutherford. Okay, I repeat this. There are different models for structure of atom. The first one to come up was Thomson's plum pudding model, J.J. Thomson's plum pudding model, according to which an atom is a positive sphere with electrons randomly embedded inside. Okay, now what is the major drawback of this model? According to this model, this is not hollow. It is full of matter. But what do we know today? An atom is empty inside, right? After Rutherford's experiment, we concluded that an atom is mostly empty inside. 99.99% of an atom is empty space. If you compare an atom with your classroom, if you compare the size of an atom with your classroom, the size of the nucleus would be that of a pinhead. It is so tiny. I'll give you another example. You know, all of us are made up of atoms, right? All of us are made up of atoms. I am made up of atoms. You are made up of atoms, right? Okay, so if I remove all the empty spaces from my atoms, and if you do the same thing, if every single human being on earth does the same thing, all of us, the 10 billion people now, 10 billion people, if we remove all the empty spaces from our body, from the atoms inside our body, on our body, you know, the entire mankind, entire population on earth, 10 billion people could fit in a sugar cube. Okay, it is so empty. Atom is so empty and hollow. We are all so hollow. All right. Anyway, this is the concept which was given after Rutherford's experiment. Rutherford's experiment was also called alpha particle scattering experiment, gold foil experiment, because he used gold foil for it. Okay, or Geiger and Marsden experiment. So there are 4 names for it. I'll come back to the experiment later. Rutherford's experiment, gold foil experiment, alpha particle experiment, Geiger and Marsden experiment. Okay, there are 4 names for it. Okay. Anyway, according to this experiment, after this experiment, what do we conclude? All right, after this experiment, we conclude that an atom is empty, nucleus is at the center, electrons are around it. Okay, but that was also discarded after, you know, there are certain problems with it. You have learned the drawbacks of Rutherford's model. What is the problem? I'll roughly tell you, because according to Rutherford's model, an electron is revolving. Revolving electron is accelerated electron. And according to classical electromagnetic theory, accelerated electron should emit energy. energy, h nu. So what happens? Upon shedding energy, it is getting tired and it is spiraling. Eventually, it is falling into the nucleus. All right. This is what Rutherford's model would take you to, right? According to Rutherford's model, electron is revolving. What is the problem with the revolution? Revolving electron emits energy, emits photons. What is the problem with emission? When it emits energy, there will be continuous loss of energy. Imagine you are running for the whole day. At the end of the day, you can't even stand up. Why? Because you don't have energy. Same way, electrons would spiral, and eventually collapse into the nucleus. But that never happens, right? Which means this model has some problems. So then Bohr came and gave his postulates. What are Bohr's postulates? That's a standalone question, 3-mark question, important one. What are Bohr's postulates? Number 1, electrons cannot revolve anywhere they want. They can revolve only in certain non-radiating orbits called stationary orbits. I repeat, electrons cannot revolve anywhere they want. They can revolve only in non-radiating orbits. Non-radiating orbits. In such orbits, electrons won't radiate energy. All right. And such orbits are called stationary orbits. And second postulate is called quantization condition. In such orbits, angular momentum of electron. In such orbits, angular momentum. This is called angular momentum. Mass of electron, velocity of electron, radius of orbit. Angular momentum of electron is equal to integral multiple of h by 2 pi. 1 h by 2 pi, 2 h by 2 pi, 3 h by 2 pi. Likewise, n can take different values. N is quantum state, principal quantum number. N is equal to 1, n is equal to 2, n is equal to 3, like that. H is Planck's constant. Okay, this is called Bohr's quantization condition. Bohr's quantization condition. That means angular momentum is quantized. Quantized means packet. Angular momentum comes in packets. Angular momentum comes in packets. Which packet? One packet is h by 2 pi. This is second postulate. Third postulate, an electron might make a transition from a state of higher energy to a state of lower energy. In this process, it might emit a photon whose energy is the difference between energy levels, EI minus EF. EI minus EF. So these are Bohr's postulates. Bohr's postulates is an important question. Number 1, electron cannot revolve anywhere they wish. They can revolve in certain non-radiating orbits. They are called stationary orbits. Second one, angular momentum of electron is an integral multiple of h by 2 pi, nh by 2 pi. Third one, an electron might make a jump, de-excitation, from a higher energy state to a lower energy state. In this process, it emits a photon whose energy is equal to EI minus EF. This is what Bohr said. Okay, now I'll write few equations. First equation is this. You have to learn these equations. First one, orbital radius is given by n square h square epsilon 0 by pi m e square. N square h square epsilon 0 by pi m e square. Then energy is given by minus 13.6 divided by n square electron volt. You know, it seems deleted, but still it is better to learn these derivations also. You must have done in school. Okay, radius is given by n square h square epsilon 0 by pi m e square. N is the quantum number, h is Planck's constant, epsilon 0 is permittivity of free space. N is the quantum number, h is Planck's constant, epsilon 0 is permittivity of free space, m is mass of electron, E is an electron's charge. What is this? Orbital radius. If you put n is equal to 1, you get what? 1 square h square epsilon 0 upon pi m e square. That will give you 0.53 angstrom. It has a name. It is called Bohr radius. So what is Bohr radius? It is the orbital radius for electron in ground state of hydrogen atom. orbital radius for electron in ground state. Ground state means n is equal to 1. N is equal to 1 is called ground state. N is equal to 2, first excited state. N is equal to 3, second excited state. N is equal to 4, third excited state. They are quantum numbers. Okay. Anyway, this is Bohr radius. All right. And we have a couple of more equations. I'll write. Understood until here? We will go to the questions. All of you understood? I'm trying to revise the portions as well. Okay. I'm not simply doing the questions. This should benefit areas as well. Tell me if you understood this. Hello, can we move on? Hey, no one is here. Yes, thanks for that. Right, okay, so these are the equations. MVR is equal to NH by 2 pi, H nu is equal to EA minus EF, Rn is equal to n square epsilon 0 by pi me square. Energy is minus 13.6 upon n square electron volt. And this is orbital radius for quantum number 1. It is called Bohr radius. Okay. Hope you have written this. I'll write one more thing, then we will go to the questions. You have to know 3 equations. Rn is proportional to n square by z. Rn is proportional to n square by z. En is proportional to z square by n square. What is this? There are 4 atoms. 1 H, 2 He3, 2 He, and then 3 lithium, 4 beryllium. Okay, so I have 4 atoms here. 4 atoms here. What is the atomic number of this? Atomic number is 1, which means number of protons is 1. Number of electrons is 1. So it has 1 electron. Atomic number of this is what? 2. So number of protons is 2. Number of electrons is also 2. So number of electrons is also 2. If 1 electron is gone, only 1 electron is left. This is called singly ionized helium. Singly ionized helium. Now how about this one? Lithium has 3, atomic number 3. Atomic number 3 means number of photons is 3. Number of photons is 3. Number of protons is 3. Number of protons is 3 means number of electrons is 3. Number of electrons is 3. 3 electrons. 2 electrons are gone. It becomes doubly ionized. If 2 electrons are gone out of 3, 1 electron is left. Then look at this. 4. There are 4 protons, right? Atomic number is 4, right? 4. So, for 4 protons, 4 electrons. If 3 electrons are gone, it has 1 electron. So, what is the common characteristic you have here? All these atoms or ions have only 1 electron each. These are called hydrogenic atoms. Hydrogenic atoms. Why should I learn this, or why should we learn this? Because Bohr model could be applied only to hydrogenic atoms. Bohr model could be applied. This is the drawback of Bohr model. One of the drawbacks of Bohr model. One of the drawbacks of Bohr model. Bohr model could be applied to hydrogenic atoms only. That means atoms with 1 electron only. What if there are more electrons? If there are more electrons, there will be complex electron-electron interactions. Complex electron-electron interactions. So, we can apply this Bohr model to hydrogenic atoms only. So, we derive these equations for hydrogen atom. That is why you don't see Z in it. Look at this. In this equation, there is no Z, right? In this equation, there is no Z. Because we derived it for these equations for hydrogen atom. Z is 1. Z is 1. Okay. But if you do it for other atoms, it will look like this. For example, if in the question, if hydrogen atom is mentioned, take Z as 1. Okay. And if helium is mentioned, take Z as 2. Lithium, Z is 3. And beryllium, Z is 4. Okay. So, you can do accordingly. And last one, velocity of electron. velocity of electron is given by 1 by 137 into C by N into Z. 1 by 137. This is what? Velocity of electron. Where? In a hydrogenic atom. In which state? Quantum number N. For example, if they say ground state of hydrogen. If they say ground state of hydrogen. How do you find velocity? Ground state of hydrogen. Ground state means what? N is equal to 1. N is equal to 1. So you have to put N is equal to 1. Hydrogen atom means what? Z is equal to 1. You put Z is equal to 1. You solve it. You will get 2200 kilometer per second. That is the velocity of electron in the ground state of hydrogen atom. Ground state of hydrogen atom. Or if they say first excited state of beryllium. First excited of beryllium. First excited means N is equal to 2. First excited means N is equal to 2. You put it here. Beryllium means 4. Put it here. Solve it. You will get it as 4400 kilometer per second. Understood that part, all of you? We will go to the questions then. You can write this down also. Okay. Trust me, this is very important. Okay. So we'll go to the questions now. Someone could tell me, please. Oh guys, I'm doing this for you. Please, please help me. I know you have your priorities. You might be learning other topics. But after all, this is exam. So we sincerely wanted to help you. Okay. All right. So we had to cut other schedules down so as to give slots for you. Right. So just if you attend this session, you'll get questions for sure. Trust me. Right. So moving to the next one now. So let us go to the question now. In the nth orbit, energy of an electron is given. The energy required to take electron from first orbit to second orbit. E1. What is E1? Minus 13.6 by 1 square. Energy is minus 13.6 by n square. For first ground state, you put 1. That is minus 13.6 electron volt. First 4 values, if you learn by heart, that would be better. That is what my suggestion is. What is the second state? E2. This is called first excited state. 13.6 divided by 2 square. You solve it. You will get minus 3.4 electron volt. Now E3, that is minus 13.6 divided by 3 square. That is, if you solve it, you will get minus 1.5 electron volt. Now last one, E4, the fourth state, energy, corresponding to the fourth quantum number 4. That is minus 13.6 divided by 4 square. That is also called third excited state. That is going to be minus 0.85. Here they are saying from first orbit to second orbit. First orbit to second orbit. Energy required is the question. So you can take what? First orbit to second orbit. What is it? That will be like E2 minus E1. First orbit to second orbit. E2 minus E1. What is it? That is minus 3.4. First orbit, that is n is equal to 1. Second orbit, n is equal to 2. First orbit, this one. Second orbit, this one. They can ask any other as well. So minus 3.4 minus E1 is 13.6. That is minus 3.4 plus 13.6. That is going to give you 10.2, right? 13.6 minus 3.4 is 10.2 electron volt. Is it there in the options? Yes, answer is option A. All of you got it? Everyone got it? Yes, Rishabh. Very good, Rishabh. Tell me, other guys also, please. Everyone. Okay, Humayed, very good. Can I have more responses, please? The more you respond, the better you're going to do in exam. Okay. All right. Anyway, what to do? Right. Okay. So let us move to question number. Which one of the series is hydrogen spectrum is in visible region? Which of these is in visible region? Hydrogen spectrum as such doesn't seem to be included in syllabus, but again, we have to be safe, right? So let us not take chances. Which of the series of hydrogen spectrum is in the visible region? You know, hydrogen spectral series is generally given by 1 by lambda is equal to 1 r into 1 by nf square minus 1 by ni square. 1 by nf square minus 1 by ni square. Okay, 1 by lambda is equal to r into 1 by nf square minus 1 by ni square. Now nf can take 1, 2, 3, 4, 5, 6. 1. Lyman. 2. Bohr. 3. Passion. 4. Bracket. 5. Fun. 6. Humphrey. Humphrey is not there in syllabus. So I am writing them one by one. 1 by lambda is equal to r into 1 by 1 square minus 1 by ni square. 1 by lambda is equal to r into 1 by 2 square minus 1 by ni square. Okay, 1 by lambda is equal to r into 1 by 3 square minus 1 by ni square. 1 by lambda is equal to r into 1 by 4 square minus 1 by ni square. 1 by lambda is equal to r into 1 by 5 square minus 1 by ni square. Now these are the different parts of hydrogen spectral series, right? Now first one is called Lyman series. Lyman series. Second one is called Bohr series. Bohr series was the first one to be discovered. That was discovered by a Swedish school teacher named Bohr. Okay, and Bohr is the most important as well. Oh, sorry, my bad, right. This is Lyman. That is general expression, right? That is general expression. I must be writing this as general expression. I didn't tell you what R is. R is called Rydberg constant. That is called Rydberg formula. This is the value for Rydberg constant, 1.097 into 10 to the power 7 per meter. Why per meter? 1 by lambda. Lambda is meter now. Lambda is meter now. Right. Lambda meter means it's on denominator. So meter raised to minus 1. So I can write everything now. First one. First series is called Lyman. Second series is called Bohr. Second series is called Bohr. Third series is called Passion. Fourth is called Bracket. And fifth is called Fun series. Okay. P is silent here. You pronounce it as fund, not P fund. Okay. And you know what are the numbers here? Ni can start at what? 1 is already taken here. So the next number 2, 3, 4, etc. up to infinity. That is called series limit. Series limit means end of series, infinity. Now Ni is equal to, what about this one? Here 2 is taken. So you can take 3, 4, 5, etc. up to infinity. Now next one, Ni is equal to 3 is taken. So first number is 4, 5, 6, etc. up to infinity. Next, Ni is equal to what? This is 4 is taken. 5, 6, 7, etc. up to infinity. Last one 5 is taken. So Ni is equal to 6, 7, 8, etc. up to infinity. Now what can they ask? Lyman belongs to which part? Ultraviolet. You check the wavelengths, go back to electromagnetic spectrum, check it out. You will see that these wavelengths belong to ultraviolet region. In electromagnetic spectrum, these wavelengths will belong to ultraviolet region. What about Bohr? Bohr belongs to visible, violet, indigo, blue, green, yellow, orange, red. VIBGYOR. That is our visible light, right? Visible light. Okay. Then Passion, Bracket, Fun. All of them belong to infrared. If you are being precise, this is near infrared, and this is middle infrared, and this is far infrared. But anyway, in general, you can say all are infrared. Okay. Now this is one question. Where do they belong? We have the question here. Which one of the series of hydrogen spectrum is in the visible region? They are talking about visible region. They could ask this question about anything. Visible region. Visible is what? Visible is Bohr. So the answer is Bohr series. Understood this, all of you? This is very important. Bohr series. Visible is Bohr. All of you got it? Yes. Many are already there with answers. Okay. And another question that can come is what? they will ask you to find the longest and shortest wavelengths. Longest and shortest. How to find longest? How to find longest? Can someone tell me? How to find longest? How to find longest? Can you please tell me how to find the longest? Put the first number. Put the first number 2. Put the first number 2 here. That will give you longest wavelength. In terms of R, you can retain. You don't have to substitute for R. Okay, usually you don't have to substitute for R. Do you hear me? Do you hear me? How do I know if you hear me or not? Tell me, guys, please. What is this? You have an exam day after tomorrow, right? Please. Okay, Aman, thank you. Right. So anyway, longest wavelength is by putting the first number, longest wavelength is by putting the first number, and shortest wavelength is by putting the last number. Longest first, shortest last. Longest first, shortest last. Longest by putting the first number, shortest by last number. Longest by first number, shortest by last number. Longest by first number, shortest by last number. Longest by first, shortest by last. Okay. And second question is, they will ask you to find wavelengths of H alpha, H beta, H gamma lines. What are H alpha, H beta, H gamma lines? H alpha, H beta, H gamma lines. Where is Balmer? The first 3 lines. They are called H alpha, H beta, and H gamma lines. The first 3 member lines, they are called member lines. The first 3 member lines of Balmer series are called H alpha line, H beta line, and H gamma line. First 3 lines. That means you put Ni is equal to 3. Ni is equal to 3 into this. You will get some lambda, right? That will be H alpha lines lambda. Then put Ni is equal to 4. Then you will get what? H beta lines lambda. Then Ni is equal to 5. You will get lambda, H gammas lambda. H alpha, H beta, H gamma, and X is H delta. H delta is by 6, putting 6. That is our second case. Understood this, all of you? Shall we go to the next question? Let's make it quick. I have maybe 25-30 minutes to finish it off. All of you? All right, Devika, Johan, Sneha, all of you. Thanks for responding, everyone. Right. Okay, the ratio of kinetic energy to total energy of electron in an orbit is. This is again important. Again important. You must have done this in school for sure. Okay, total energy, kinetic energy to total energy. I'll write all of them here. Kinetic energy of an electron is E square by 8 pi epsilon 0 r. Kinetic energy. Potential energy of an electron is minus E square by 4 pi epsilon 0 r. And the total energy of electron is minus E square by 8 pi epsilon 0 r. This is what? These are all energies of electron in a hydrogen atom. Energies of electron in a hydrogen atom. Why should I particularly talk about hydrogen atom? Tell me. Hydrogen atom is the simplest atom. Why is hydrogen atom simplest atom? Hydrogen atom has only 1 proton and 1 electron. 1 proton and 1 electron, no neutron, no complications, no strings attached. Okay, so hydrogen atom is the simplest guy. You have to trust him, and then you are finding his kinetic energy. Electrons kinetic energy, electrons potential energy, electrons total energy. Even if you don't learn this, it's okay. I don't care. But this you have to learn. I am finding the ratio, kinetic energy to total energy ratio. That is very important. That will help you in numericals also. Kinetic energy to total energy ratio. If you find the ratio, you divide them yourself, you will get E square cut, 8 pi epsilon 0 or 8 pi epsilon 0 r cut, only minus will remain. So that will be minus 1. This ratio is very, very important. Or you can say kinetic energy is equal to negative of total energy. All right, that is first point. So here the ratio is minus 1. I'm also writing a couple of more things. First, potential energy to total energy ratio. Can you tell me potential energy to total energy ratio? What is it? Potential to total. This by this. So minus E square, pi epsilon 0, r, everything cut. 1 by 4 by 1 by 8. 8 goes to numerator. So that is 2. Cross multiply, you can write potential energy is equal to 2 times the total energy, right? So learn these equations by heart, right? Why? I can tell you one numerical. They will ask you to find the kinetic energy of electron. Kinetic energy of electron in a hydrogen atom. How do we get it? Kinetic energy is equal to what? Minus of total energy. That is minus of total energy we learned already, minus 13.6. Minus of minus plus 13.6 by n square electron volt. So you can use this equation to find kinetic. Otherwise it is difficult. You have to use this shortcut. How to get kinetic energy? I have no direct equation. So I'll take kinetic energy as negative of total energy. Negative of total energy. Why should I go to total energy? Because total energy, I have an equation, minus 13.6 by n square. So I seek the help from total energy. Got it? Right. So he is helpful, minus of minus plus 13.6 by n square. Now I can put the number, quantum number they will give you. They will say what is the kinetic energy in the second excited state. So n is equal to 3. Third excited state, n is equal to 4. Or even total energy, potential energy we can find out. 2 times total energy. What is it? 2 times minus 13.6 by n square. That will be minus 27.2 by n square. Minus 27.2 by n square. 27.2 by n square. So if you learn these shortcuts, you can find kinetic energy anytime, potential energy anytime. Otherwise, trust me, you are never going to do this. 100% sure. So trust me on this. These questions are very, 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 very important. Okay, all of you got it? Can I have a response very quick? Right. Tell me please. Tell me please, Johan, check it out again. Understood, Johan? Everyone. Let's make it quick. All right, Martin, thank you. Rest of the guys, there we go. All of you. Right, Sneha, Amman, Johan, everyone, Martin, Humaid, Russell, Mohammed. Tell me, Rishabh, all of you. So, moving to the next question now. Right, the radius of hydrogen atom in the ground state is 5.3 into 10 raised to minus 11. Ground state. So, ground state radius is given 5.3 into 10 to the power minus 11. Now, the questions will be easy for you. After collision with an electron, it is excited, right? When electron collides, there is excitation, right? So, its radius will increase. Radius is what? Radius is 21.2 into 10 power minus 11. What is the principal quantum number? What is the principal quantum number of the final state? Easy. I wrote an equation. R is proportional to n square by z. N square by z. But forget about z. Why? I'm talking about hydrogen atom. Hydrogen atom Z is what? Atomic number is 1. So I am writing R1 is equal to, how to remove the proportionality? Constant into N1 square. R2 constant into N2 square. So R1 by R2, what is it? K and K are cut. N1 square by N2 square. Nothing. You have two conditions, you have two equations, you're just putting them and solving them. That's it. What is so complicated in it? So simple. Easy, it's cakewalk for you. Right. R1 is given 5.3 into 10 power minus 11. R2 is given 21.2 into 10 power minus 11. N1, quantum number for hydrogen. Yes. Ground state. It is ground state. Ground state means what? N is equal to 1. So for hydrogen it is ground state 1 square by the other quantum number I have to find out, N2 square. Cut this and this. These will definitely cut, 100% sure. That's going to be 4 here. 5 4s are 20, right? 5 4s are 20, right? So 5.3 into 4. Now I have N2 square on right side, 4 on left side. Take the reciprocal. 4 is equal to N2 square. Take the square root. 2 is equal to N2. So quantum number is 2 for the second atom. Second atom quantum number is, second state it is 2. It's also called first excited state. All of you got it? Everyone got this? Everyone got this? Yes, yes, Rishabh. Very good, very good. Rishabh has come up with the answer. Right. Very good. Right. Now why you're worried? Now you are all prepared. You're all set for the examination. Then what? Okay. Very good, Johan. Thank you. Right. Moving to the next question. In Bohr's model, atomic radius of Bohr orbit is R0. Then the radius of third orbit. Very direct question, easy question. But it's a previous one. Bohr radius. You know what Bohr radius is? The first one, right? Bohr radius is first one. So you can say, again the same question. Radius is proportional to n square by z. N square by z. Okay. For simplicity, let us take hydrogen atom. Even otherwise, when you take the ratio, it will get cut. Same atom, right? Do you want me to retain it? No. Why make things complicated? Anyway, you're going to take the ratio, that z will get cut for sure. Okay. So I'm taking this R1 is equal to K N1 square. R2 is equal to K N2 square. Actually, there is an Z on denominator, but Z I take 1 because they haven't specified the element. Element can be what? Anything from this. Hydrogen, singly ionized helium, doubly ionized lithium, triply ionized beryllium. Okay. So tell me what? I can take the ratio. R1 by R2 is equal to K and K are cut. N1 square by N2 square. What is R1? First radius is given. R0. R2 is to be found out. What is number 1? State 1. They are saying about first orbit. First orbit. First case is first orbit. N2 I have to find out. Right. N2 square. Right. Did I make any mistake? Oh, no. N2, no. I have to take second case is third orbit, right? Third orbit is given. Third orbit means 3 square. Third orbit means 3 square. That is also called second excited state. Cross multiply now. R2 will be what? You can cross multiply. R2 will be what? R2 goes here and 3 square goes here. 3 square is 9. 9 into R0. Is that there in the options? Yes, answer is option C. All of you got it? All of you got it? Yeah, thank you, Rishabh. Thanks for that. Not last 4 chapters only. All chapters are going to be easy. No, don't worry. You trust me. Right. All of you got it? Shall I go to the next one now? Let's make it very quick. I might take 15 more minutes to finish it off. So thanks for staying with me. Thanks for staying there. Thanks for motivating me. Right. So let me just finish it off. Moving to the next question, the ratio of longest to shortest wavelengths in Bohr series. Longest to shortest. Bohr series. So I'm writing Bohr series equation. 1 by lambda is equal to R into Bohr is 1 by 2 square minus 1 by Ni square. So longest I'm finding first. Longest. Longest by putting which number? The first number, right? Longest by putting Ni is equal to 3. Because this is 2, right? It should be starting at 3. So longest by putting 3. 1 by lambda is equal to R into 1 by 2 square minus 1 by 3 square. So that will give me 1 by lambda is equal to R into 1 by 4 minus 1 by 9. So take LCM. 1 by lambda is equal to R into 9 comes here, 4 comes here. 9 minus 4, that is 5. By LCM is 36. Take lambda, lambda longest, I call it lambda longest. Take the reciprocal, 36 by 5R meters. I got the longest. Now I can find the shortest. How to find the shortest? By putting the series limit. 1 by 2 square minus the last one, 1 by infinity square. 1 by infinity square, the last one. So R into longest by putting the first number and shortest by putting the last number. 1 by 2 square is 1 by 4 minus 1 by infinity is 0. So 1 by lambda is R by 4. Take the reciprocal. So lambda shortest is 4 by R meters. So I got lambda longest. I got lambda shortest. Am I correct? Lambda longest, lambda shortest, right? Okay, so I can, what is the question? Longest to shortest. So lambda longest by Lambda shortest is, lambda longest is what? 36 divided by 5r divided by shortest is what? 4 divided by r. So r and r are cut, 4 and 36 cut, 9. So answer is 9 by 5. Is that there in the options? Yes. Option B is correct. Now this could be asked for any series, Balmer, Lyman, Paschen, bracket or Fund. All of you got it? Answer is option B. Yes, Johan, very good. Right. Yes, yes, yes. Okay. All of you, everyone, come on, please. All of you, longest to shortest wavelength ratio in Balmer, they can ask in Lyman, they can ask in Paschen, bracket or Fund. So change the series accordingly. This is a general expression. This is Balmer, right? You can change this number to get any series. If you put this number 1, Lyman, put number 2, Balmer, 3, Paschen, 4, bracket, 5, Fund. Okay. Now moving to the next question. Which state of triply ionized beryllium has same orbital radius as that of ground state of hydrogen atom? Again a previous question. Triply ionized beryllium has same orbital radius. I am searching for my keyword here. This is the keyword. Look at that, the beautiful guy. The orbital radius, right? Same orbital radius. Look at that. Same orbital radius. So that is the condition. Same orbital radius. So given that orbital radius for beryllium is same as that of hydrogen atom. Can you read it again? Which state of triply ionized beryllium? I said before that beryllium is a hydrogenic atom. Beryllium is a hydrogenic atom. You don't remember? Look at this. Beryllium is a hydrogenic atom. Lithium is a hydrogenic atom. Even helium is a hydrogenic atom. Hydrogen is already hydrogenic atom, right? Okay. Anyway, look at this. Beryllium. So they are talking about beryllium and hydrogen. They say they have same orbital radius. What is the equation for orbital radius? I write it here. I have written so many times now. R is proportional to n square by z, or R is equal to k n square by z. So I am writing this k into n square by z for beryllium is equal to k into n square by z for hydrogen. So let us put the values. Let us cut the numbers now. K and K are cut, right? So let us put all the numbers. Tell me, what is n? Beryllium's quantum number. Which state of beryllium? Which state of beryllium? So beryllium's number I don't know. Divided by beryllium Z. What is beryllium Z? Z for beryllium is 4. Atomic number of beryllium is 4. So 4 is equal to. What about hydrogen? They say ground state. Ground state means 1 square. Ground state is 1. Of hydrogen means 1. Cross multiply now. N square is equal to 4 or n is equal to 2. The quantum number is 2. Quantum number is 2. That is called first excited state. All of you got it? All of you got it? Can I have a response, please? Everyone, please. Right, maybe 30 more minutes. You're going to get like 3 or 4 mark questions from this. Okay, I'm trying to cover the whole syllabus as well. Okay, I'm not particularly sticking on to the numericals only. I'm giving all the associated questions and the relevant concepts as well, so that you can do any question that comes your way. Got it? Any question that comes your way. Any question. Right. How many spectral lines are seen for hydrogen atom when electron jumps from n is equal to 5 to n is equal to 1? Electron de-excites. De-excitation. Electron is falling down from a higher energy state to a lower energy state. Higher energy state to a lower energy state. Okay, electron is falling down from a higher energy state to a lower energy state. How many spectral lines are emitted? So there is a shortcut for it. It is a previous foreign paper question. I'll tell you the shortcut. Very, very, very important. N into n minus 1 by 2. The number of spectral lines emitted when an electron de-excites from an excited state to ground state. Excited state to ground state. Excited state to Ground state. What if it is non-ground state? Such a question won't come because that's a typical JEE question, JEE examination question, NEET examination question. Okay, for boards, we will always end at ground state. It is coming down from excited state. Electron jumps from this state to this will be always 1. That will always come to ground state. Always come to ground state. I can put the numbers here. What is the number? 5 into, this is 5 minus 1 divided by 2. Okay, that is 5 into 5 minus 1, 4 by 2. That is 20 by 2. That is 10. So what are those transitions? From 5, no? It is coming down from 5, right? 5, right? So 5 to 4, 5 to 3, 5 to 2, 5 to 1. Next is 4 to 3, 4 to 2, 4 to 1. Next is 3 to 2, 3 to 1. Next is 2 to 1. So it is starting at 5. So 5 to 1, 5 to 4, 5 to 3, 5 to 2, 5 to 1. 5, then next number is 4. 4 to 3, 4 to 2, 4 to 1. Next number is 3. 3 to 2, 3 to 1. Next number is 2. 2 to 1. So how many altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Altogether 10. 10. I'll mark 10. No, absolutely wrong. They got me here, right? Absolutely wrong. This is not the correct answer. You got the shortcut, then what is the problem? I didn't read the last word, in the visible region. In the visible region. If that is a clause, that is a condition. If they simply stop here, n1 is equal to 1, the answer would be 10. But what is the trap here? They have put that last word, visible region, right? What does it mean? Visible region means what? Visible region. Do you remember? Lyman, ultraviolet. Lyman, ultraviolet. Balmer, visible. Passion, infrared. Bracket, infrared. Fun, infrared. So, Balmer is in visible region. Balmer, you are looking at something in Balmer. They are asking particularly about visible region. Visible region. Balmer. Balmer equation, do you remember? Balmer equation, you remember? 1 by 2 square minus 1 by ni square. So it should end at 2. End at 2. So you have to count the transitions ending at 2. Count the transitions ending at 2. Look at the orange arrows here. 5 is coming to 2. 4 is coming to 2. 3 is coming to 2. So how many transitions are there? Even though there are altogether 10, only 3. So the correct answer is 3. Trust me, this is a very important question. It can come as a 2-mark question also. It will come in MCQ also. Understood this, all of you? No, you can't say. CBSE will strict, but they might put like questions like this because they'll, if they decide, like I said yesterday, you can't score 100 that easily. 99 would be okay, but 100 that easily. Got it? In physics particularly. So they might put one question like where you might fall in trap. Okay? They might try to lead you the wrong way. Okay, anyway, do not fall in the trap. That's it. That's what I want to tell you. Okay, hope it's clear, everyone. Maybe like 10 more minutes. Now I got like 3 more slides. That's it. Finished. Okay, I'll make it very quick. Question number, these are from nuclei. All right, these are from nuclei. The ratio of radii of nuclei of Al27 and X52A is 3 by 5. The number of neutrons in the nuclei of X will be. Okay, you learned this equation in class. R1 by R2. What is the equation for R? Radius of a nucleus. Radius of a nucleus is directly proportional to mass number raised to 1 by 3. Radius of a nucleus is directly proportional to mass number raised to 1 by 3. So you can write R is equal to a constant into a raised to 1 by 3. Radius of a nucleus is directly proportional to a raised to 1 by 3. This is mass number, also called nucleon number. Nucleon number. Who are nucleons? The resident particles of a nucleus. Resident particles of a nucleus. Inside the nucleus, the particles are called nucleons. Who are they? Who are they? Who are they? Neutrons and protons. Neutrons and protons. Electrons are outside. Electrons are outside, right? Inside the nucleus, only neutrons and protons are present. They are called nucleons. They are called nucleons. Okay, so they are called nucleons. Then what? Radius is given by, nuclear radius is given by R0 into A raised to 1 by 3. A is called mass number or nucleon number. A is called mass number or nucleon number. Nucleon number. There are important points coming up. So R1 by R2, if I write it for two cases, you know what will that be? A1 by A2 the whole raised to 1 by 3. R0 gets cut. Okay, so I can put the value here. That is the equation I'm going to use. R1 by R2 is equal to A1 by A2 the whole raised to 1 by 3. What is radius in the first case? Oh, radius ratio is given. The ratio of radii is given. It is 3 by 5. Okay, 3 by 5 is equal to A1. First nucleon number is given, 27. Nucleon number is the mass number, right? And second nucleon number you have to find out. It is A, the whole raised to 1 by 3. Now how to get rid of this 1 by 3? Take cube on both sides. Cube. When you take cube of this, 3 into 3 into 3, that is 27. 5 into 5 into 5, 125 is equal to. When you take the cube, that raised to 1 by 3 gets gone, right? So you have what? 27 by A. Cut 27, 27. A will be what? Mass number will be 125, 125, 125. Look at that. Answer, you got the answer here? All of you got it? 2 more questions to go. I might need like 5 more minutes to finish it off. Okay, can I have a response, please? Yes, yes, very good, right. So moving to the next question. This is again an important one. I'll tell you about mass defect and binding energy. That is an important part. What is mass defect? Imagine I have few nucleons. You know, the blue ones are neutrons and the orange ones are protons. Blue ones are neutrons, orange ones are protons. Okay? Blue are neutrons, orange ones are protons. They combine to form a nucleus. Okay? They combine to form a nucleus. Imagine. Alright. So we have few nucleons. They combine to form a nucleus. Okay? Now let us take the element. This is the element. This number is called atomic number. Atomic number is number of protons. And this number is called mass number, which is number of protons plus number of neutrons. So this number is what? Proton number. This number is what? Protons plus neutrons. So what is neutron number? A minus Z. So I can say number of protons is what? Number of protons is Z. Number of neutrons is what? Number of neutrons is A minus Z. A minus Z. Look at that. This is called a nuclide. Okay. In a nuclear species, X is A, some random element. Z is atomic number. Atomic number is number of protons. And this number is mass number, which is nucleon number. It is protons plus neutrons. So the difference will give you number of neutrons. So look at this. I'm going to find the mass of this guy. Mass of this. Mass of the nucleons. What is it? There are mass of a proton is MP. Mass of a proton is MP. MP. Okay, 1 proton. 2 protons, 2 MP. 3 protons, 3 MP. 4 protons, 4 MP. Z protons, ZMP. What have I got now? Total mass of protons, right? Total mass of protons, right? Total mass of protons. What is mass of a neutron? Mn. Mass Okay. Hello guys, we are back. We had a technical glitch. Hope you can hear me. Humaid, Johan, all of you. Two more questions, it's done, finished. Can I have a response, please? Can I have a response, please? Okay, right. So this is very simple. We have like a single proton whose mass is mp. One proton's mass is mp. So z proton's mass is zmp. One neutron's mass is mn. A minus z mass neutron's mass is a minus z into mn. So this is the total mass of all the nucleons. And mass of nucleus is what? Nucleus. This is mass of nucleus, that is mn. And you expect them to be equal. But it is not so. They are not equal. Okay. Which is bigger? Mass of nucleons is slightly bigger than mass of nucleus. That sounds quite funny, right? Look at this. Because when you weigh the nucleons independently, Zmp plus A minus Z into Mn, this is total mass of nucleons is slightly greater than the mass of nucleus. The difference between the masses is called mass defect. What is mass defect? I can find the mass difference. Is Zmp plus A minus Z into Mn. Okay, this is mass of nucleons minus mass of nucleus. This mass is called mass defect, and this is converted to energy using the equation, Einstein's famous equation, delta mc square. It is used to bind the nucleons inside the nucleus. So it's very simple. When you go from here to here, some mass is lost. Where is it lost? It is converted to energy. It is used to tie the nucleons together. That is called binding energy. This is called binding energy. Okay, they might ask a numerical here. Nothing. They will give you Z value, MP value, A value, Mn value, Mn value. You can substitute all the values to find mass defect. Multiply that by C square. You will get the binding energy. Do not do that. Do not multiply by C square, because this is all going to be given in atomic mass unit. Atomic mass unit. Atomic mass unit is what? It is roughly 1.66 into 10 power minus 27 kilogram. This is a unit used to measure the mass of subatomic particles. It is a unit used to measure the mass of subatomic particles, very tiny particles, 1.66 into 10 raised to minus 27 kilogram. So this will be in AMU, this will be in AMU, everywhere AMU. So once you have done this, multiply that by 931.5 mega electron volt instead of C square. Never multiply by C square. Even though you write C square, multiply by 931.5 million electron volt. Why? Why? Because if you convert this mass to energy, this mass, you will get this number, 931.5. I'm leaving that as an assignment to you. It is a reader question. Convert this mass, 1 AMU, to energy using this equation, mc square. You will get this number. So what are you supposed to do? You put all the masses, you take all the difference, then what? Get the mass. Do not multiply by C square, multiply by 931.5. Okay, that is called energy, binding energy. And finally we find binding energy per nucleon. Binding energy per nucleon. What is it? It is the total binding energy divided by number of nucleons. Number of nucleons. Binding energy per nucleon. Why do we find it? It is a measure of stability of the nucleus. Stability. The more the binding energy per nucleon, the more is the stability. Did you hear me? The more the binding energy per nucleon, the more is the stability. When binding energy per nucleon increases, stability increases. They might give a question. They will give you two elements, maybe lead and something else. They will ask you which one is more stable. How will you do it? How will you do it? All the numbers will be given. Put those numbers in here. You will get the binding energy. Divide that by number of nucleons. You will get binding energy per nucleon. See which element has more binding energy per nucleon. That will be the stabler one. That will be the stabler one. Okay. So the one with more binding energy per nucleon will be the stabler one. The binding energy per nucleon is more means stability is more. So if they give two elements, do them separately. First you do it for lead. You do all these steps, calculate it. You'll get something. Some million electron volt. Then divide that by mass number of that element. You will get binding energy per nucleon. Repeat the same thing for the second element. See where you get greater number. The one with more binding energy per nucleon is more stable. Understood this? Understood this? You will do binding energy per nucleon for both cases, and then you will find the one with more binding energy per nucleon. More binding energy per nucleon. That will be more stable. We even have, if you want to take a screenshot, you take it. Okay. You know, we even have a curve, binding energy per nucleon curve. Binding energy per nucleon again is mass number. 1, 2, 3 peaks are seen here. This is helium, this is carbon, this is oxygen, and iron is at the top. Okay, and there are inferences you learned in class. I don't have time for it. I'll come back to the question. This is graph is very important. Binding energy per nucleon graph. Helium, carbon, oxygen have peaks, which means they have more binding energy per nucleon. They are more stable than their neighbors. Iron has highest binding energy per nucleon. Iron's binding energy is like 8.5 million electron volt. Okay, anyway, forget about that. Let us come back to the question. It's easy now. Then masses of neutron and proton are, this is neutron's mass, proton's mass. Neutrons and protons combine to form a helium. Neutrons and protons combine to form a helium. Helium nucleus. Helium nucleus is what? He24. Helium nucleus is He24, right? How many protons? 2 protons. How many neutrons? 2 neutrons, right? Oh no, tell me. Right. See, hydrogen. How is helium formed? Helium, He24. How many protons? Number of protons is 2. Number of neutrons is what? 4 minus 2, that is 2. So I can say 2 protons plus 2 neutrons gives a helium, right? I am supposed to find what? The binding energy of helium nucleus. How to find the binding energy? How to find the binding energy? Find the total energy on the right side. Find the total energy on the left side. Take the difference. What is the total energy on the left side? 2 into. What is mass of proton? I can find the mass difference, right? What is the mass here? 1.0087 plus. This is 2 into mass of proton. 2 into mass of neutron is given? Yes. It will be there on the first page of the booklet also. 1.0073. Alright. This will be the total mass, right? Total mass. I can calculate it for you. I'll just calculate it. I'll use the calculator for the time being. Just give me a second. So that number is going to be 2 into, can someone help me with it? 1.0087. So 2 into 1.0087 is 2.0174 plus. Second number is 2 into 1.0073. That is like 2.0146. So 2.0146. 2.0146 plus 2.0174 is equal to 4.032. Okay, so 4.032, this is the mass, total mass on the left side. Minus, what is the total mass on right side? Helium's mass is given. What is helium's mass? 4.0015. So I can get delta M here. What is it? 4.0015 is 0.0305. They are asking you to find the binding energy. How to find the binding energy? How to find the binding energy? I had asked you to multiply this number you get 0305 with 931.5, because this is obtained in atomic mass unit. Understood that point, all of you? Understood that point? What did I do? I found the total mass on left side. Total mass is what? 2 into mass of proton plus 2 into mass of neutron. I get this number. Mass on the right side is helium nucleus. Helium nucleus is given 4.0015. So take the difference. That will give me mass difference. Mass difference. Multiply them. Now that is 0.0305 into 931.5. 931.5 is what? 28.4. Yes. Answer is 28.4 million electron volt. All of you got this? On to the last question. I'll wind up. All of you, everyone, can I have a response, please? Option A. Okay, last question here. Read the question. The binding energy of deuteron is deuteron 1s2 is 1.112 binding energy per nucleon. Per nucleon, watch out for this. That is a trap again. Per nucleon, 1s2 per nucleon. There are 2 nucleons, right? 2 nucleons, right? So total binding energy will be into 2. And alpha particle has binding energy of 7.047. Then in fusion reaction, I am writing that reaction. 1s2 plus 1s2, they have given a reaction here. 2He4. 1s2 plus 1s2 gives 2He4 plus Q. This is a fusion reaction. Energy Q released is. What is fusion reaction? You know what it is, right? Yesterday I told you fusion is nuclei combined to form a heavy nuclei. Light nuclei combined to form a heavy nucleus. Okay. Fusion, thermonuclear bombs. Thermonuclear fusion bombs. Okay. Right. Anyway, fusion, that is something happening in sun. Right. Nuclear energy is enormously large. With 1 kilogram of uranium fuel, you can run a huge warship for 20 long years. 20. With 1 kilogram of uranium fuel, you can run a motorcycle for 15,000 years. 15,000. Nuclear energy is enormously large. Understood? Right. Anyway, there are 2 reactions, fission and fusion. Learn examples for fission and fusion. Fission has example uranium breaking into barium and krypton. Chain reaction. Uranium splitting into barium and krypton. Alright, there are many examples, but the best one is barium and krypton. That will result in a chain reaction. Controlled chain reaction is power reactor. Uncontrolled chain reaction is what happened in Hiroshima and Nagasaki in 1945. That is called atom bomb explosion. Alright, that is fission bomb. Fusion bomb is yet to be detonated. Right, it is highly destructive, fusion bomb. Forget about that. Anyway, I'm going to find the energy released. Energy released, how will you find it? Find the total mass on left side. What is mass of left side? Mass of left hand side. I am writing 1s2 plus 1s2, right? 1s2 plus 1s2. How many nucleons? 2 plus 2. 2 nucleons here, 2 nucleons here. So altogether 4 nucleons. Binding energy per nucleon. Binding energy per nucleon. You might not see this. I'm really afraid of this, scared of it. You know, per nucleon is given. For 1 nucleon, 1.112. So for 4 nucleons, 4 into 1.112. That is what? 4 into, that is 4.448. Okay, what is mass of, oh no, this is binding energy, not mass. Binding energy on the right side. I simply call energy of LHS. What is energy of RHS? Energy of RHS, it's given, it seems, 7.047 MeV. Now you are finding the Q, energy released. Energy released is called Q value. How to find it? Just find the energy difference between. Q value is nothing but energy on the right hand side minus energy on the left hand side. Okay, it is 7.047 minus 4.448. That's going to give you 7 minus 4.5, 2.5, somewhere around 2. Did I make any mistake? Oh, again, I made a mistake. I'm really sorry. My bad. Right. See, mass on the energy on the right side, I didn't foresee that. So that is what my problem is. ERHS. Kindly forgive me for that. Again, it is 7.047 per nucleon. I asked you not to forget this, but I forgot myself. Per nucleon. So what about right side? How many nucleons? How many nucleons? How many nucleons? 4 nucleons on the right side into 7.047. Okay, I didn't see that coming. Okay, you know, I gave you a warning, but I myself fell in the trap. You know, this is per nucleon. Here also it is per nucleon. Binding energy per nucleon. For helium also, there are 4 nucleons. 4 into 7 is somewhere around 28 point something. 28 point something. I don't mind what it is. Anyway, what I need is a Q value. What I need is a Q value, which is E right hand side minus energy on the left hand side. The energy released in the process. It is 28 minus 4.448. Roughly 28 minus 4.5, 24.5. Somewhere 23.8. The closest value is 23.8. Understood this? All of you got it? Everyone got it? So I'm trying to wind up now. We have done almost all important questions from dual nature of matter and radiation, atoms and nuclei. That is something beyond imagination because it couldn't have been done without your cooperation. You responded very quickly. I'm really thankful for that because I could finish these many questions. All the important areas are touched. Now show that nuclear density is a constant is a very important descriptive question from this topic. Show that nuclear density is a constant or nuclear density is independent of mass number. Second question, properties of nuclear force. Properties of nuclear force and graph of nuclear force. Graph of nuclear force. Graph of nuclear force or energy. You draw it this way. This region is for repulsive. This region is for attractive. Negative force is attractive. Okay, so if you are ready and willing to come, tomorrow we might have a quick revision session. Maybe we'll take like 1 hour to have a very quick run through the topics. All right. From the beginning till the end, we will tell you all the important areas that could come in the examination that will help you for your final preparations. Now, if you are ready to come, just give me a thumbs up. Okay. Now, and if possible, share the link with your friends as well. Okay. Try to bring in as many people as possible because anyway we are spending time, so let them benefit as well. So thanks for coming. Thanks for staying back. See you. Hope to see you tomorrow. If you're not joining tomorrow, let me wish you the very best. Do not be afraid of anything. Just be a fighter and then fight it out. This is going to be your battle. You are never going to lose it. Trust me, this is the 21st year of my teaching. I have seen people doing wonderful things. All right. People who have failed in all exams, you know, people who have got 0 in exams, school exams, people who are so desperate getting to the top in the end. Okay, it's all because of the consistent hard work and the confidence that they maintained. Okay, so just be confident in yourself. I told you, you are the last one to trust you. All right, your parents could trust you, your friends could trust you, your teachers will have belief in you. But eventually, when it comes to you, you are the last guy who is going to be confident in you. Right. So let that be your triggering point and give your best in the exam. If you're not joining tomorrow, let me wish you the very best. My prayers are with you. All the Excel team, the entire Excel team here wishes you the very best in exam. Try to join tomorrow if possible because we are going to tell you the most important areas to focus in the final day of preparation. So see you guys tomorrow. I'm signing off. Bye. Thank you. Thank you very much. Thank you very much. Bye.